and it's called conditional probability. And that is probabilities can change if we are given certain pieces of information. Let's break down this idea of like conditional, right? Where have we seen that kind of word before?
Terms and conditions.
Terms and conditions, right? Like in the T's and C's that no one reads, there are some conditions applied if you want to sign up for something and make an account. Harriet.
Air condition.
Air condition. I don't know how I'm going to relate that to this one. But yes, thank you. There's another type of conditional, and if any of you do IPT, you would know. Yeah, we have something called, what's a conditional statement? What is that?
It's like if it's true or false, or if it relies on an external thing.
Sort of, right? Like if this is true, then do this. It's just kind of like flow of logic. If this is true, then do this. Conditional probability relies on a similar kind of idea. If we're given certain pieces of information, the probabilities change. Now, initially that may seem a bit strange, but I've actually given you an example of that before. If you remember the thought experiment or the game show.
Well, that was fun.
Yeah. Well, you don't know what it's called?
The game show.
The game show problem. It's actually called
The three-door
problem. It's the Monty Hall problem, right? And the idea is that if you are given some information, they tell you where one of the goats are, right? The probability changes. Again, initially seems strange, but I'll give you examples. Hopefully that can make it a bit clearer why that happens, right? So for example, let's use our Venn diagram from last time. We drew a few, but I'm going to draw one of them. And this is the one where I think it was iPhones and red peas, right?
Mm-hmm.
So people with iPhones and people with red peas. I can't remember the exact numbers, but I think it was something like this. So here's our Venn diagram. From this, we want to find the following. Alright, let's look at the first one. We've got 11 people in this class, and we have our two sets, iPhones and red peas, A and B. Okay. So first of all, what's the probability that we have people with iPhones? Well, how many people have we got? We've got 8 that just have them, 1 that has both.
Me.
That's you.
Special one.
So what's that going to be? That's 9 yeah, out of 11.
How? There's 9, 10. No, 9. There's only 10.
Someone who doesn't have either.
Okay.
Yeah.
Other than 2 people.
Yeah, there were
Wait.
2 people
Were
that
there
didn't
2
have
people?
either, and then there were
Ah.
2 people which had their P's but didn't have an iPhone.
Sure. So what do we want to change that? We can't bother.
It doesn't really
It
matter.
doesn't really matter. Let's go with this example. Sorry, I couldn't remember the numbers exactly, so I kind of made it up. What about P of B then?
There's 2.
There's only 2.
It's 2 out of 11. Still hasn't changed. What happens now if I give you some information? And this idea of A and B with this vertical line here is saying this.
A and B.
Well, we've looked at A and B, haven't we?
Oh, yeah.
What would A and B be? What would A and B be? A and B, right? What if I have A and B? That's actually this section here, right? That's the intersection.
Is he saying neither A nor B?
So this one here, or neither A nor B would be out there, right? This is think about conditional, right? The condition is this. What if I want to know the probability of A given that B is true? So this idea of this line is we can say it as A given B. A given B. Okay, so what I mean by that is, okay, if I already know that this person has their red peas, what's the probability they have an iPhone?
Oh, 1.
Just one? How do I write it as a probability?
Apple.
So, given that they have their red peas, I'm telling you this person, they've got their red peas. What's the chance they've got an iPhone?
1 and 2.
1 in 2. How'd you get that, Colin?
Because there's 2 people with red peas and one of them has an iPhone.
Okay, so I think Laura immediately saw 1 there, and she's like, yeah, there's a 1 there, and exactly right. But remember, what does probability mean at the end of the day? Probability, we need to work with sample spaces, right? We need to work with, hang on, A given B. So I know that this person definitely has their red peas, right? So we've got 2 people with their red peas. And how many of them have iPhones? Just 1 of them, like you said. So,
I'm not doing all of this, but it was different.
so it's just 1 over 2. You've done this
You
before?
know when we shaded in all the different stuff?
Yeah. It's kind of a.
Isn't that just
Similar,
shading in the middle bit? And it was not that.
So we are kind of shading in this middle bit here, but something else is happening. What else are we doing? I'm not just shading it in, right? Where does this denominator come from? Out of this circle now. Because what was our original sample space? Our original sample space is how many people in the class? There's 11 there, right? And now we're changing it. Now our sample space is 2, right? Okay. Let's look at the next one. Important to note, right? A given B, what would B given A mean?
Given
Like-
A.
So like A is the sample space and who's in B.
Right, so what's the kind of wording, what's the language that we might use for this one?
Given A.
B given A. Is that it?
Yeah, B given A, but what would it mean in terms of these things here?
Given A.
Like A and the intersection between them.
Just like use like English, like well how I did before. Right?
Use English, guys.
So
Don't overthink it. Don't
They
overthink it.
have the iPhone.
Yes, right.
Probability that they have their pick. Someone.
Right. Okay. And the reason why I say use English is because when you start using like these letters, and that's how they might give it to you in a question. But that's not how we naturally think and understand a problem, right? So let's see. Use what Matt said again. He said, all right, given A is true, right? Given A is true, right? So I know that this person has an iPhone. What's the probability they have their red piece? That's what that means in English, right? Does that kind of make things a bit
1
clearer?
out of 9.
See how easy it is once you understand the language of it?
Yeah.
So 1 out of 9.
So we're doing some English in here?
We are. It's the marrying of two subjects
I
that
hate
are normally
that.
equal.
English and
Normally
maths
against
works
each other.
with 2 subjects, including business,
1 out of
which
9.
we have next.
Questions about that one?
Including business.
Okay, as you're writing these, let's just unpack the language a bit, right? So
Let's don't get ready.
one of the hardest things in probability, again, is just unpacking language and interpreting the question. So here's our question, right? We've got 2 math tests. 25% pass both, 42% pass the first one. Okay, so that's the information we're given. Now I ask, what percentage of people who pass the first test also pass the second? And the thing you might be wondering right now is thinking, why are we dealing with percentages when we're talking about probability? But if you kind of think about it, right, these things here, these are just percentages. They're the chance of something happening, we can express those as percentages. So,
No way.
so for this condition, can we try and think about this idea here, right? If I set A and B, what do I know is true?
You know they passed the first test.
I know they passed the first test, and I'm looking for what percentage passed the second one, right? So think about the information you're given, right? How can I work that out?
Easy.
Yeah.
So PAV.
So if we go back to probability, right, these are 2 very closely related things, all right? When you're finding the percentage, that's actually the same as finding the probability of this thing, right? Oh, hold on. So how many people pass both? There's 25%. But what other information I'm told? I'm told that 42% pass the first one. How'd you work it out? Someone help me out.
Well, like the way I think about it, like 42 like passed the first one,
Mm-hmm.
and then like a certain percentage passed the second one.
Mm-hmm.
But like if you multiply them together,
Yeah,
shouldn't that equal 10? Well, it's not my correct thing.
that makes sense. Yeah. What do you guys think?
Wouldn't it be like 25? I mean, in a fraction form,
Mm.
0.25 over 77.
Why did I say 7%?
25 plus 42.
So you're adding these things together now? Is that what you're kind of thinking?
Yeah.
Yeah. What do we think?
Sure.
Um,
Well, worth a try.
I think the tricky thing with this one is like, yeah, it's kind of hard to wrap your head around these things that are kind of related together in some sense. What do I actually do with these numbers? Okay. Have a think about what happened with the probability. When we were given some information, what actually changed? What value changed when we were given some information from the first 2 to the second 2? The denominator. And what does the denominator represent? It represents the sample space, right? So in a sense, this condition, we're restricting the sample space, right? In this case, we're restricting it to people who had red Ps. This one, we're restricting it to people who had iPhones. This one, we're also restricting the sample space. What are we restricting it to?
To the people that passed and in the crossover.
Yeah, well, what are we restricting? We're restricting to people who passed the first test. Right, can you kind of see that? Right, because I'm only interested in what percentage of people who passed the first test also passed the second. Right?
Isn't it just 25?
So
If
hey,
they pass
read the question carefully. What percentage of people who passed the first test also passed the second?
67.
So because 42% passed the first one, 25% passed both. Right?
So you just plus them together.
But hang on, so they have to. I'm not looking for. I've got these things here individually, right? We can see that very clearly. Okay. But what's the Look carefully. What's the thing I'm interested in? What percentage of people who passed the first test? So they definitely passed the first test.
Of the some passed the yes.
How many people, like, how many of the 25% also passed the first one?
No, because that's the thing.
Yeah.
Because they passed both tests.
You're just saying who passed.
They did pass both tests, right? I'm looking for what percentage of people passed both tests, but
It's 25, it's right there.
No, but they couldn't.
That 25% is almost trading the 42
Do you mean
like
like-
it's 100.
what do I mean?
Hold on.
Yes, give me 1 second. Make sure I know. The problem is this, right? You can pass the first test, but you can fail the second test, right? But what I'm asking for, I'm not asking for what percentage of people passed both tests. That's not what this question is asking for. I've got the information. Laura's right.
It's like the reciprocal of how people failed the second one or the first one.
Well, if you take the reciprocal, I think you're going to get more than
No, but like-
1%.
You're like finding how many people failed the second test but passed the first test.
Yeah. So let me just go back to what Laura was saying, right? So what am I actually restricting? I'm not looking at the whole class anymore, right? She's watching carefully here. What percentage of people who passed it? That's what I'm assuming. I'm assuming that they passed the first test. How many people
Wait.
passed? What percentage of people passed the first
Are you,
test?
just,
42.
are you just finding how many what percent of the first, like the people who passed the first test passed the second one?
Right. Yeah.
Is it just
That's correct.
like 25 and
Because-
42?
That's exactly what it is. Yeah, yeah. Let me unpack the language
In the
again.
probability.
Sure.
Yeah. So this is related to what we're doing here. Okay.
Yeah,
So
I did it, but-
does that kind of make sense? Do you want to have a go to explain that
That
again?
was the thing that Matt
You-
said like first.
It's saying like what percentage
What
of
did I
people who passed the first test
Mm.
also passed the second. So it's what percentage
Get
of the
that.
42%.
Yeah, that's what I mean. That's what Matt
Passed
said. That was the
second
first thing
test.
that Matt said.
Okay.
I
Yeah,
think
sorry.
that-
I agree with what you were
I
saying before.
divided it.
I agree with what you were saying before. So let's just unpack it again, right? So make because it's not an easy concept, right? So I've got this information. 25% passed both, 42% passed the first one. Okay. But what I'm trying to see is, okay, of these people, of these 42%, right? Not all of them passed both of them, right? Some of them passed the first one, and then someone failed the second one. But some of them passed both, right? So of these people, out of these 42%, how many of them passed both? 25% of the class passed
Okay,
both.
no, I see.
But out of these people, because once you take the 42%, right? I don't know, I can't do that. I can't do 100 circles, right? But-
Okay, so I see.
yeah. So of these people here, right? These people, let's say these people passed the first one. These people, in red, I'll draw it. These people failed. Right? So far, so good. So what I'm saying is, of these people here, right? Some of them passed both. How many of them did? How many people passed both of these? 25%. Say like that. They passed both. I don't know. Right? Right, so this is, let's say this represents 25% here.
Yeah.
Right? But of the people who passed the first one, how many people passed both? Can you see how they're different questions? Right? Can you see how it's not going to be 25% for this answer? Does that kind of make sense? Right?
60%.
Is that kind of getting clear? You're gonna work with it, yeah? Right. So of the people who passed the first one, how many of them passed both? It's not 25%. That's 25% of the whole class, right?
My brain just clicked.
Does that make sense now? Does that make sense? Okay, so what's up? It's the same thing here. What's happening? Our sample space is being restricted. It's being changed. What's the sample space now?
People who passed the first test.
Yeah, which is 42%. So the percentage, or you can think about it as a probability as well, is equal to, right? Well, on the denominator we're going to have 42%, or you can write that as 0.42, whichever is easier for you. And how equal past both? 0.25. What's that going to be?
Yes.
Like rounded to 60%.
0.59.
Yeah, what is it? 0.5?
0.595.
Is there a lot of decimals?
Yes. That's 30.
There's 3.
That's the best.
There's like
the
7.
3 decimal places.
There's a lot of this.
You can write it as a fraction?
25
over 42.
There's the fraction.
Of course. That is the fraction.
So in the end,
So either way. That's conditional probability. It's this idea that you're given a piece of information, and how does that change the probability? Right. How can we formalize this?